Welcome back. All right, we have one giant task left to do, which is to make the press and hold buttons for our camera presets. But before we do that, we want to talk about just a variety of smaller little things that we didn't get a chance to touch on in other places in the class. Just to show you a couple of things. We're not going to integrate them into our design, but things that you should be aware of, either conceptually or just kind of for fun. So first thing to talk about are loops. We haven't really used loops in this class. I showed you an example of a loop in the infinitely scalable interlocking buttons section, but we really haven't employed them. I will say this, when you go into the Lua class, you're going to use loops all the time. You're going to use loops for everything. Loops are really useful in creating repeated actions that can bring in various inputs and create different things along the way that the block controller doesn't always quite have the right hooks for. We've seen that a couple of times already in class where block controller doesn't quite give you the ability to customize this one thing, and if you could shove this one thing in there, then it might make your life a little easier. Keep in mind, again, block controller is a learning tool. It can't be as infinitely flexible as pure Lua coding is, or else it would just be Lua coding directly. But you still might find that loops are useful in different cases. And there are 3 different loops that you can build with the block controller. We call them the while loop, the for loop, and the repeat loop. So these are 3 instances of that loop being built. And each of these loops will actually output the exact same thing, which is it's going to debug print for you the numbers 1 through 10. And the way it does it is as follows. On the left, we have a global variable x, and we're going to start that variable off as being set to number 1. And then we have a while loop. What the while loop does is the first thing it does is it checks a condition, and if that condition is true, then it will execute its loop, and at the end of its loop, it'll go back and recheck the condition. So right now, our condition is that x is not equal to 10. Well, guess what? 1 is clearly not equal to 10. So because it is not equal to 10, that yellow block resolves as true, and it executes the code. Our code is to reset our variable x to equal the current level of x plus 1. So now x equals 2. Now it goes back up, it runs the code again, it checks the condition. 2 is not equal to 10, so it runs it again. And it keeps on running it until x does equal 10, which will happen after 10 of those loops. And then that will tell it to not do the while loop 10th time, or an 11th time, I suppose. And along the way, it debug prints it each time. So that's the while loop. It checks something first, and then it runs its code. Jumping to the far right side, we'll skip the middle momentarily. The far right side is the repeat loop. The repeat loop is doing something very similar. First, we're setting our variable, in this case, z, to 1. This time, though, it says repeat until. Now, even though the until is at the top of this little event handler, it doesn't check it until the end of its loop. So what it does is it does the loop once. Here it's doing the same thing. It's taking z and it's iterating it plus 1 and then debug printing it. And then after the loop is done, it checks to see if its condition has been met. And now in this case, it will repeat until that particular yellow block is also true. So when z is greater than or equal to 10, when z has become 10, it'll stop. So the difference between these two things may seem subtle, but the key to keep in mind is that the while loop asks whether it should start. It says, is this condition true or not? And if it's true, then I'm going to run it. While the until loop asks for a reason to stop. It will run the loop once no matter what. It automatically does that, and then it checks if it should stop. So same idea, but different conditions on when it begins or whether it stops. Then there's the middle one. Middle one is the for loop. This one says, for index ranging from 1 to 10 by 1. What does that mean? Okay, we've seen indexes before. We've seen how that's just you counting the number of items essentially in an array. Here we've got what you would call an array of the numbers 1 through 10. So it's really just saying 10 times. Do it number 1, then number 2, then number 3, then number 4, all the way up to 10. Just do it 10 times. And we're increasing it by 1 each time, which is pretty normal. There's not a lot of instances where you'd probably want to do it by 2s or by 3s, but I don't know, maybe you're aligning it with something weird that's else in your design, whatever. It's basically saying do this 10 times. And then it's going to here do the same thing. Take variable y, add 1 to it, and continue. This one is not validating on any conditions. It is not checking something external to see whether it should start or checking something external to see if it should stop. It's just going to do it 10 times because that's how many times you told it to do it. Now, are you going to be using any loops to add 1 to a variable over and over again? Probably not. These aren't very useful instances of the code. This is just showing you how the loop works. In Lua, you could use these loops all the time to create event handlers for an array of controls, or to traverse an array and do something for every single item in that array, looking at its index and its value. You can use loops like crazy. And if you take the advanced class, which, if you're feeling comfortable at this point, you probably should, then Jeff's going to tell you all about loops, and you're going to use them constantly. For us, we don't really have a lot of instances inside this block controller class where the loops are that useful for us. But if you need them, you'll see them. One thing I do want to point out is that if you create a loop that does not stop, then Q-SYS will prune your results and it will stop you. It'll give you this notification saying max execution limits exceeded. Well, what does that mean? So this is by design. We want the system to prevent something from occurring that will potentially be problematic, right? If you are running an infinite loop, it needs to be able to anticipate that and stop it, because otherwise it's going to try to do it infinitely, and then eventually your PC will break down. It'll crash, right? If computers crash, that's probably what's happening. It's doing something that it can't resolve in the time it needs to resolve it. So let's create a broken script for ourselves really quickly. Jump back to your design, and I'm going to grab a brand new block controller. And we're just going to drag it anywhere. It doesn't matter where. And let's create a loop that will break itself. A couple of different ways you could do this. Why don't we do one that's similar to those loops that we just did, where we're going to iterate by 1. Let's go into our block controller. I'm going to create a variable. We'll call this variable my number. And we'll start that number off as 1. And then let's go to our flow control and make a repeat while. And remember that the while is looking for a true. Whatever is in this input has to resolve as true in order for it to keep going. So let's just grab the word true and shove it in there. That way, no matter what, it will always keep going because it'll always analyze that. And guess what? True is always going to be true. So no matter what we put in here, boy, oh boy, it's not going to stop the loop. But let's do that same thing where we're going to add by 1. So we're going to say that my number, we're going to set my number to its current value plus 1. That way we'll be able to see how many times this executes. And we will debug print the end result of my number. Grab that from right up here. And we will jump into emulation mode so that we can have our debug window tell us what happens. And look at that. Within the blink of an eye, it did this 28,570 times, and then we got max execution limits exceeded. So in one moment, it ran through that loop nearly 30,000 times. It detected that it's doing the same thing 30,000 times, and it said to itself, you know what? I have no idea if this is ever going to stop. I don't know if you've written an infinite loop or not. So what I'm going to do is I'm going to cut it off. I'm going to say this is not efficient. We're just pruning it out. You don't get to do this anymore. It's pretty unlikely that you're going to have a legitimate reason for a loop that executes 30,000 times. If you do, I don't know what to tell you. You got something going on in your system that maybe you could probably think of a more efficient way to handle. That is an expected and desired result, that Q-SYS will prevent you from doing something that's too big.
There are like maybe one instance in Q-SYS programming where you might legitimately run into this. It really is an advanced sort of application that you probably would be doing in the full scripting. We'll talk more about it in the scripting version of this class, but the bite-sized version of the issue is usually if you have a really big JSON file that you are working with, you might run into that? And the answer is use the Rapid JSON library. But all of that probably sounds like mumbo jumbo and is a really great invitation for you to continue your journey into Q-SYS scripting, where we can talk about these things because they're useful. They're just, it's just different. It's next. It's the next thing.
The way that you would be most likely to accidentally create an infinite loop, because you're not going to accidentally create this while loop here, but the way that you may make the mistake is if you have a function that recalls itself within the scope of that function. Like if I make a function here, and we're going to call this function Brittany, and if in the course of that function it recalls Brittany, then what it's going to do, it's going to run Brittany, and the act of running Brittany means it needs to run Brittany, and it will never even be able to resolve that original function because it's just creating this infinitely deep version of Brittany. So let's debug print that one as well. I'll debug print me. Yeah.
Nate, oops.
It's the oops loop.
It's the oops loop.
Oops.
It's the oops.
I did it again.
I did it again.
So check your oops loop. Let me disable this one here since we don't need that. And same thing, you can see that we will start our script. Let's recall our function, or else it won't work.
You have to start. This is called recursion for those of you who are playing at home, and this is a wonderfully clever looping mechanism that loops based on logic versus looping off of the other constructs. It's really clever, but let's see the oops loops.
Oh yeah, it's there. Now in this case, I didn't do any iteration to show you how many times it did it, but it did it about 28,570 times, and then our max execution limits was exceeded. And boy, would it be easy in any of the blocks that we've created, right, to maybe think you're clicking one function in one of these drop-down menus and you accidentally click the function it's starting in. So that's probably where you would be most likely to find this as you're building out.